Hello boys and girls, this is Mr. Kizik, and in this video we're going to be we're going to be starting and looking at trigonometry. So when students hear the word trigonometry, they get, just a little bit flustered because they think this is such a difficult topic, won't be able to understand it. But as long as you realize or just follow these different ratios here, it's really not too bad. So really, what is trigonometry? Really, trigonometry is just the study of triangles. And that makes sense because what's the prefix in trigonometry? It's triangles. And what about triangles? Well, it's really about the ratios of them. So what we're going to be talking about here, as it says, each acute angle of a right triangle has the following ratios. So this only works if the triangle is a right triangle. So we have our first trig function, which is called sine. Sine is the ratio of the leg opposite the angle, remember it's the acute angle, to the hypotenuse. So if I look at the drawing right here, sine of A, well, so here's A right here. Well, what's the side opposite of A? Well, that would be, if I drew an arrow, little a. So it's little a over, what's the hypotenuse? C. Now, what's sine of B? Well, the ratio for sine of B is if I just take B right here, drew an arrow opposite to that, it would be little b over C. So that is sine. Cosine, as it says here, is the ratio of the leg that's adjacent to the angle and to the over the hypotenuse. So if I look at cosine of A, so here's A again. Now technically there are two sides that are adjacent to the angle. There's little b and little c. However, what did we just say before that little c was? Little c was the hypotenuse. So that's always going to be the hypotenuse, and that's it. Even though technically it's adjacent to big A here, being the hypotenuse supersedes it. So the adjacent side to little a is, to big A is little b over the hypotenuse. Same thing with cosine of B. Which side is adjacent to angle B? Well, it's both little a and little c. However, little a is the one that's adjacent because c is the hypotenuse. So it's a over c. And then tangent is the ratio of the leg opposite the angle to the leg that's adjacent to that angle. So again, remember, C is always a hypotenuse, so that's not going to change. So when we talk about the adjacent side, we never include the hypotenuse. So tangent of A, as it says, the ratio opposite, which was A, over the leg that's adjacent, B. Likewise for tangent of B, it's the side opposite of it, B, over adjacent, A. And what's interesting about trig functions is if you look here, the sine of A is the same thing as the cosine of B, sine of B is the same thing as cosine of A, and then the tangent of A and the tangent of B are just reciprocals of each other. So basically what that means is that if I have some sort of angle, whatever A is, there's only one angle that corresponds to that specific ratio. So if I look here, it might be hard to remember what is sine, what's the ratio for sine, what's the ratio for cosine, what's the ratio for tangent. Well, to help us remember that, there's a little mnemonic thing to help us remember. And it's called SOHCAHTOA. And what that means is is sine is equal to the opposite over the hypotenuse. ha means that cosine is equal to adjacent over hypotenuse. And then TOA is tangent is equal to opposite over adjacent. Okay. So if I look at some examples here just for the ratios, if I just look at this. If I look at number 1, this is given each triangle here, or find each trig ratio as a fraction in simplest form. So if I look here, first thing is sine of A. So if I look, A is right here. If I refer back to the previous box here, sine of A is just taking the opposite side over the hypotenuse. So what is the opposite side of A? What's the length of that? If I drew an arrow, that would be 5. So it's 5 over which side's the hypotenuse? Well, it's always opposite of 9 degrees, and that's 13. So 5 over 13. And that is your answer. Let's look at cosine of A. So in this case here, cosine of A, the ratio is adjacent over hypotenuse. So the side that's adjacent to A, that's not the hypotenuse, is 12, and then over the hypotenuse, 13. So 12 over 13. And then the tangent of A, looking previously in that box, is you take the opposite side over the adjacent. So tangent of A, the opposite was 5, and the adjacent was 12, so 5 over 12. And that's it. And now I'm going to do the same concept on the other side, except now I'm looking at C. So if I look here, sine of C, well, sine is opposite over hypotenuse. So what's opposite? What side is opposite of C? 12. What's the hypotenuse? 13. Now I look at cosine. Cosine is adjacent over the hypotenuse. So it's 5 over 13. And then tangent of C is just you take the opposite side over the adjacent. So 12 over 5. And that's it. Remember, these ratios only work for acute angles, so you will never be asked for the ratio of, or the sine of, say in this example, B, because, well, what is, and the reason being, and this is something more when you get into pre-calc or algebra 3, is if I took the sine of B, for example, well, the sine of B, remember the ratio is opposite over hypotenuse. So what side is opposite of B? Well, it's 13. Well, what side is hypotenuse of, or what's the hypotenuse? It's still 13. 13 over 13 is 1. So the sine of any right angle is always going to be 1, and that really doesn't tell us anything here. Okay. So what do these ratios really mean? Like, what does sine A equals 5 over 13, like what does that actually mean? Well, that means there's some angle A, that if I take the sine of that angle, the ratio is going to be 5 over 13. Always. Alright, let's look at number 2. Now, number 2, same concept. Find the angle measures, or find the angle ratios based on the right triangle. Now, if you notice here, there's something missing in this triangle. You're missing WX. Well, in order to do that, you have to do a little bit of Pythagorean theorem. So remember, Pythagorean theorem is a squared plus b squared equals c squared, where c is the hypotenuse and a and b are the legs of my right triangle. Well, in this case here, we are finding the hypotenuse, so our sub is going to be 9 squared plus 12 squared equals c squared. And then it's just a matter of doing the math here. 81 plus 144 equals c squared. Then you add 81 and 144. You get 225. and then take the square root of both sides, and you are going to get, I believe, 15. Yes, 15. And so C is equal to 15. So now I can go about doing the trig ratios. So to find sine of W, W is here. It's opposite over hypotenuse. So it's 12 over 15. But in this case here, 12 over 15 can be simplified to 4/5. Like, as it says there, you always want your fraction, just like you did in algebra, always want it in the simplest form. Cosine of W is going to be adjacent by hypotenuse, so it's going to be 9 over 15, which again can be reduced to 3/5. And then tangent of W would be opposite over adjacent, so it's going to be 12 over 9, which again can be reduced to 4/3. Sine of X, so now I'm going to look at X here, but again using the same ratios. Sine of X is going to be opposite, so 9 over the hypotenuse, 15, which is going to be 3/5. Cosine of X is going to be adjacent over hypotenuse, so 4/5. And then tangent of X is going to be 9 over 12, which is 3/4. And that, ladies and gentlemen, is how you do trig ratios. So what I would like you to do is, as if we were in class here, I would have you guys try number 3 on your own. So pause the video, try number 3 on your own, and then unpause the video to see if you got the correct answer. Alright, so welcome back. So hopefully with this here you realize I need to use the Pythagorean theorem. So again, I would have a squared plus b squared equals c squared. Now in this case though, I'm not solving for the hypotenuse, I'm solving for one of the legs. So it does matter what value goes where. So I would have a squared plus 16 squared equals 34 squared. So then I would just do the math. 16 squared is 256. 34 squared is 1156. I'm going to subtract 256 from both sides. I'm going to subtract 256 from both sides. Going to get 900. And then I'm going to take the square root of 900. And I'm going to get 30. Alright. So then once you found that was the difficult part really. Now you just do the ratios. So sine of L, opposite over hypotenuse. So 30 over 34. Which, make sure you do reduce, is 15 over 17. Cosine of L would be adjacent over hypotenuse. And again, make sure you reduce. Tangent would be opposite over adjacent. So 30 over 16, which again can be reduced. And do the same thing for sine of M, for the M angle. So sine of M, 16 over 34. Cosine of M would be 30 over 34. 15 over 17. And then tangent of M would be 16 over 30, which is going to give me 8/15. So that, ladies and gentlemen, is how you do trig ratios for right triangles. I'm going to stop the video here because for the next section I do want to be there with you because it involves your calculator. So this is a little quick lesson here. So for homework, not much for homework. Just want you to do number 1. That's it. So just do number 1 for homework, and next class we will, or go over how to do how to find missing how to find missing sides of right triangles. Remember, if you got any questions, please feel free to email me. This is Mr. Kizik, signing off.